In today's digital age, understanding how Bitcoin works has become increasingly important. Bitcoin, the world's first cryptocurrency, operates on a revolutionary system that combines cryptography, computer science, and economic incentives. Let's dive deep into how Bitcoin actually functions and what mining Bitcoin really means. At its core, Bitcoin is a decentralized digital currency that operates without the need for intermediaries like banks or governments. Instead, it relies on a vast network of computers worldwide that maintain and verify all transactions. This network is what makes Bitcoin unique. It's not controlled by any single entity, but rather by thousands of participants working together. The foundation of Bitcoin is the blockchain, a public ledger that records every single transaction ever made. Think of it as a giant spreadsheet that everyone can see, but no one can tamper with. When you send Bitcoin to someone, that transaction is broadcast to the entire network and needs to be verified before it's added to this ledger. This is where Bitcoin mining comes in. Mining serves two crucial purposes. It creates new Bitcoins and validates transactions. Miners are essentially powerful computers that compete to solve complex mathematical puzzles. When a miner successfully solves a puzzle, they earn the right to add a new block of transactions to the blockchain and receive newly created Bitcoins as a reward. The mining process is intentionally difficult and resource-intensive. This is what's known as proof of work, POW. The system is designed so that, on average, a new block is added every 10 minutes. As more miners join the network and computing power increases, the puzzles automatically become harder to maintain this 10-minute average. The mathematical puzzles miners solve aren't actually useful calculations. They're more like a lottery where miners repeatedly guess numbers until they find one that produces a specific result. This process requires enormous amounts of computing power and electricity, which is why Bitcoin mining has become increasingly industrialized, with large mining farms operating thousands of specialized computers. When a miner successfully mines a block, they're currently rewarded with 25 Bitcoins, plus any transaction fees included in the block. This reward halves approximately every 4 years. It started at 50 Bitcoins in 2009, dropped to 25 in 2012, to 12.5 in 2016, and to 6.25 in 2020. The next halving is expected in 2024, reducing the reward to 3.125 Bitcoins. This controlled supply mechanism is one of Bitcoin's most important features. Unlike traditional currencies, which can be printed at will by central banks, Bitcoin has a fixed maximum supply of 21 million coins. This scarcity is built into the code and is one reason why some people view Bitcoin as digital gold. But how secure is this system? The beauty of Bitcoin's design lies in its economic incentives. To attack or manipulate the network, you'd need to control more than 50% of the total mining power, a scenario known as a 51% attack. However, acquiring that much mining power would be enormously expensive, and if you did succeed, you'd likely crash the value of Bitcoin, making your investment worthless. The transactions themselves are secured through cryptography. Each Bitcoin wallet has two keys: a public key, like your email address, that others can use to send you Bitcoin, and a private key, like your password, that you use to send Bitcoin to others. This system ensures that only the rightful owner can spend their Bitcoin. When you make a transaction, it's signed with your private key and broadcast to the network. Miners verify these signatures before including transactions in a block. Once a transaction is included in a block and more blocks are built on top of it, it becomes increasingly difficult to reverse. After 6 confirmations, about an hour, a transaction is considered virtually irreversible. The energy consumption of Bitcoin mining has become a significant concern. The network currently uses more electricity annually than many small countries. This has led to debates about Bitcoin's environmental impact and sparked interest in more energy-efficient alternatives like proof-of-stake systems. However, supporters argue that this energy consumption is necessary for the security and decentralization of the network. They also point out that many mining operations are moving toward renewable energy sources, and that the system incentivizes miners to seek out the cheapest energy sources, which increasingly means renewable energy. Looking ahead, Bitcoin faces several challenges. The scaling debate, how to handle more transactions without compromising decentralization, continues. Solutions like the Lightning Network are being developed to enable faster, cheaper transactions by moving some transactions off the main blockchain. The regulatory environment is also evolving, with different countries taking varying approaches to cryptocurrency regulation. Some embrace it, others restrict it, and this patchwork of regulations affects Bitcoin's adoption and use cases. Despite these challenges, Bitcoin has proven remarkably resilient. From its mysterious origins with Satoshi Nakamoto to its current status as a trillion-dollar asset class, Bitcoin has sparked a revolution in how we think about money and value transfer in the digital age. Understanding how Bitcoin works isn't just about technical knowledge. It's about understanding a new paradigm of money, one that operates without central authority, but through consensus, cryptography, and economic incentives. Whether Bitcoin ultimately succeeds as a global currency or remains a store of value, its underlying